Ladies and gentlemen, this is going to be a screencast over solving absolute value inequalities. So the key is setting up the absolute value inequalities correctly to begin with. So the first thing you need to be cautious about is to be sure that the absolute value expression is isolated to the left side of the inequality. So the absolute value needs to be alone. There can't be any thing multiplying the inequality, dividing the inequality, or being added or subtracted from the inequality expression itself. And the other pattern we have to look for after we have isolated the inequality is we have two patterns to look for. The less than pattern means that the problem shows that we have the absolute value expression on this side and there's a less than sign or a less than or equal to sign. If that's the case, then we split it and do the positive and negative sandwich that we've talked about. We put the expression that's inside the absolute value in the middle, and then put the two less than signs on each side of it, place one value that we started with on the right, and then the opposite of the value that we started with on the left. Then, for the greater than problems, we're going to follow a method that's a little bit different. When we've isolated the absolute value expression, then we rewrite the absolute value expression exactly the same way that we saw it before. However, we take off the absolute value signs. And then we also rewrite it by changing the sign of the absolute value and adding a negative sign to the answer. Right. Always, 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 if you multiply or divide by a negative number, you have to change the direction of the inequality sign. So that's the same rule that we saw before when we were dealing with inequalities without absolute values. So when we add absolute values to the situation, it doesn't change the fact that we still have to change the direction of inequalities if we multiply or divide by negative numbers. So let's start with the first less than example. Go ahead and write this one down. 3 times the absolute value of the quantity x plus 6 is less than 90. Write this down and try it with the rules you saw on the last slide. Now that you're ready to check it, I hope you started by dividing both sides by 3 to isolate the absolute value. So when we divided this side by 3, then the 3 here canceled with the 3 we divided by. When we divided 90 by 3, we got 30. The next step is to make a positive and negative sandwich. So that's according to our less than rules. So we kept the x plus 6 expression in the center and just added to the front of this expression this value you see over here. The negative 30 is less than x plus 6 is less than 30. The next step is to just begin solving it. So we need to subtract 3 from all 3 parts. Subtract 6. Oh, I need to start over. Ladies and gentlemen, this is about solving absolute value inequalities. So first we need to cover the basics. The first thing you have to watch for when you have an absolute value inequality is that you have to be sure you isolate that absolute value expression by itself on the left side of the inequality. The next thing that you need to do is for less than problems, you need to follow the method that is the positive and negative sandwich. So when we have the absolute value isolated on the left side, then we simply sandwich it in between the value we started with and the opposite of that value. So typically it will be the pattern negative n is less than x is less than n. These values, recall, can be either less than or equal to. So if this had another line underneath it, then it would indicate less than or equal to, and we would still follow this less than method. For the greater than method, we follow a different procedure. So when the absolute value of x is greater than n, then we split it into 2 separate expressions. We rewrite the expression as it appeared originally, just removing the absolute value signs. And then we write it again, removing the absolute value signs, but flipping the inequality sign from greater than to less than and adding a negative sign onto the answer. The last thing that we have to remember is that the original rule that we had about solving inequality still holds when there's an absolute value in the inequality. So that means that if we happen to divide or multiply by a negative number, it's still important to change the direction of the inequality sign. All right, so here's our first example. So this is a less than example. So this is 3 times the absolute value of x plus 6 is less than 90. So if you want to stop the video for a second and work this out, and then you can check it in a second and see if you got it right. Okay, I hope you started this one by dividing both sides of this inequality by 3. Doing that eliminates the 3 from the left side, and 90 divided by 3 is 30. Now we're ready to start applying the less than example rules. So with a less than, we need to make that positive and negative sandwich. So we follow this pattern. So what we end up with is negative 30 is less than x plus 6 is less than 30. The next step will be to subtract 6 from all 3 parts of this linear inequality. So when I subtract 6 from negative 30, I get negative 6. When I subtract 6 from this expression, then I'm just left with x. When I subtract 6 from 30, I get positive 24. So that's the final answer for this less than example. All right, so here's our solution. If we graph the point negative 36 and we graph the point positive 24, then our solution is every point between positive 24 and negative 36. You see open circles at negative 36 and 24 because those are the edges of our solutions, but they are not included in our solutions. All right, so the next problem we're going to do, the next example we're going to do is a greater than example. So in this example, we have the absolute value of x plus 4 minus 6 is greater than or equal to 16. Now remember, in greater than examples, this could be greater than or equal to, as we have here. Go ahead and stop the video and try this one, and then come back and see if you did it correctly. So hopefully you started this one by isolating the x plus 4 inequality by adding 6 to both sides. So when we added 6 to the left side, then we were left with simply the inequality. But when we added 6 to the right side, we had 22. Next, we have to apply the greater than rules. So we have to establish 2 separate equations. So we'll start by saying x plus 4 is greater than 22, so we're going to leave this pretty much the same, simply taking off the absolute value signs and replacing them with parentheses. Then on the other side, we have to establish that x plus 4 is less than or equal to negative 22. So we flip the inequality sign and we flip the sign on the value in the original expression. The next step then is going to be, is to subtract 4. So from here to here, we subtracted 4 from both sides. So we got an answer of x is greater than 18 for this one. Then over here, when we subtracted 4, we got an answer of x is greater than or equal to negative 26. Then as a solution, we have 2 parts to that solution. X is greater than or equal to 18, so that's shown here, or x is less than or equal to 26, and that's shown over here. Good luck with these. Come back to these simple examples if you get stuck on one that's a little bit more complicated. But generally, the ones I've just shown you are typical of the kind you're going to be required to do for the basic evidences that we ask you to do in class.